respected Dean Madam, Principal and HOD Sir, and all the faculty members and students. Uh, Today's session is being delivered by Mr. Kiran Soni, who is a manager in Welding Engineering Department at Larsen and Toubro, Ranoli Division. Mr. Kiran Soni has specialization in welding technology. Uh, he has done his master degree post graduation from MS University with the welding technology. He is serving the L&T since last 9 years. Moreover, Mr. Kiran Soni is associated member with the Indian Institute of Welding, and he is certified welding inspector. Even he is also an ISO certified auditor. Moreover, he is acquired Best Welding Engineer Award at national level for the year 2014 during the National Welding Seminar and Weld India 2014-15, jointly organized with IIW and Tata Steel. Even he adjudged a Gold Award in Quality Circle Forum of India, Vadodara. He has secured second position in national level Young Engineer competition organized by IIW in 2018. And
Ronak, I am not able to hear you. Hello.
yes, sir.
Yeah, Ronak,
Yeah,
I am
I'm
not
sharing.
able to
I'm
hear
sharing.
you.
Yeah, I'm sharing screen.
Okay. So first of all, thanks Ronak for the introduction. And just share the screen. And if I when I ask to change the slides, please do that in behalf of me.
Yeah, sure. Yes, sir. Over to you.
Yeah, yours. Yes, I think screen is visible to all of you. So in this screen, you can see some images. Actually, I have collected specifically for the majority of students or faculties. I used to download these images and used to share with all. Is the screen is moving? There will be multiple images will be there. So yeah, it's okay. Might be you have not able to see all the images, but this images was just nothing but the creativity of a welding. So all the images were the welding was common, and from the basic welding processes, all the creativity will be there. So it's all about imagineering. Now I'm going to share with you imagineering, or I can say the creativity of L&T. So Ronak, can you please move to the next slide? Just look at the creativity. I can say the variety of material, the diameters, and the weight, what we are here to manufacture the equipment. Just go to the next slide. Next slide. So you can see the glimpse of some images of equipment manufactured at the L&T. So if you look at this equipments, like they are the largest, longest, biggest, or the superlatives are in nature. So I can say you can just image the superlative. We actually have built that superlative. So this is what the all about the L&T engineering. Ronak, next you can go to the next slide. So you can see the glimpse of some products. and capability of L&T. So this is the one of the big largest vacuum column. Next slide, please. Yeah, next. So the all the superlatives you can see. So idea behind this slide is not to brand my company or L&T, but idea behind this is that these all are the equipment are not the creativity, but also are critical in nature. So if uh, uh, any issue with this equipment and they are in the service, it may create the harm of thousands of lives. So this equipment, when we procure the plate material from the raw material to the dispatch, and when it is in a service, we need to maintain the quality, or we can say the integrity of the material, or else it will rather than the creativity, it will damage or destroy the whole thing. Just to explain that, I have covered few incident in next slides. Ronak, you can change that slides. Yeah, please. Next slide. Next. These all are the equipment, just to have you can have a visualization how they are in a size and how they are critical. But next slide, please. Yeah. So this is a of 1800 year. There is one company, RB Grover. It's a shoe factory. In this company, there was a boiler. This boiler was made by some engineers where their design was not proper, and because of that, while the boiler was in operation, it get burst. So Ronak, can you go to the next slide? You can see the condition of that company. What happens with that company? Next slide, please. Yeah, this is the condition of that company. So with the single mistake in design, or in our fabrication industry, if we leave any defect, or I can say any fabrication fault, if equipment goes to the service, it will cause thousands of life, cost thousands of lives. So when we are in the field of manufacturing, we need to think every time safety first. And for the safety, we are here to give a webinar on defects, because if we leave any defect and the defective product goes to the service, the condition will be like this. In the next couple of slides, you can see some incident like that. Ronak, you can change the slide. Yeah. Next slide, please. This is the aircraft. How because of the poor inspection, or if any defect, if defect is there in a product, and if we are unable to identify, it is also an issue. So the more importance is to avoid any defect. Second thing, if any defect is there, we need to detect that defect. And if we once we detect that defect, we need to rectify that defect. So after completion all this cycle, the final product should be of good quality. Next slide, please. Yeah, this is one of the incident of collapse of bridge. So we need to inspect once the item is in a service. Then also we have to regular check. We need to check the defect. Is there any defect generated due to service operation or not? So that we have to check. Next slide, please. Like it is at everywhere. So as I said that we need to first avoid defect at L&T. We have set our target like Airtel, zero defect in weld. So we have right now at 0.07% of meter weld that we have welded, but we are targeting to zero weld defect. So then second stage is we need to detect that defect, and the third stage, we need, once the defect is identified, we have to repair it, rectify it. So in a nutshell, if I want to say, if any customer comes to us, first of all, we need to give him an assurance that if we weld any product, it will be a defect free. So we have to give him an assurance. And once after receipt of order, we need to ensure that our product is defect free. So if any defect, we need to rectify it. But finally, the product should be defect free. It is not like the image you can say the ghadi. Ghadi is like a पहले इस्तेमाल करे फिर विश्वास करे, but it is not like that. In when the matter comes from the safety. So it's a reverse. Next slide, please. Yeah. So defect can be identified various stages, like raw material stage, that if the material is inherent defect is there, then fabricator cannot do anything. So first of all, defect to be identified at the raw material stage. Then it comes to the fabricators like L&T, where we manufacture the product, and any defect in a welding that we need to identify. And once the product is delivered, and during service, it is a requirement to identify defect during in service also. So these all are the various stages, and we all the stages we need to identify that defect. Next slide, please. Like this, in service few examinations like roof, we need to examine some aircraft or pressure vessel. Next slide. So normally the refineries takes the shutdown to identify the defect. This is a typical pressure vessel and heat exchangers that during welding, after during fabrication and in service, they are inspecting the through the some various methodologies, right? Radiographic examination that I'm going to cover in subsequent slides. Next slide, please. Yeah. So till now, I frequently use the word defect, defect, defect. But can anyone share with me what do you mean by defect? If anyone would like to share their view on the word defect, what do you mean by defect? Okay, I will explain. Please go to the next slide, Ronak. Yeah, we have various joining process available with us, like bolting, riveting, adhesive bonding, brazing, soldering, and last one is fusion, that is welding, where we are doing we actually do the metallurgical bonding up to similar or dissimilar base material. But in all the processes, joining processes, we are in a fabrication using welding, that is fusion process. Why? Because it gives us, Ronak, you can click on one slide where here we can see the definition of welding. It's the typical joining process where we apply a heat or pressure, filler metal, or without filler metal we can do weld. But the term, the last line is the homogeneous. In all the joining process, only the fusion joining, if we consider this as a joint, is homogeneous. It means the property of base material and the property of build material, when after joining, it is almost matching or the superior. So the required property in the terms of mechanical or corrosive property, the joining material and the complete joint is homogeneous. It means uniform. So if we disturb any homogeneity or the uniformity of that joint, then this Ronak, yes, this slide. If we disturb any homogeneity, then it is considered as a discontinuity. Discontinuity, if I want to explain in a better manner, like let's take you go to to get your car, new bought car, and today is your delivery. So what you do is when you go to the showroom, and once you receive that car, you just check all the points, whether any defect is there or not. So you identify 10 to 12 points that it is not meeting the requirement, like the steering has a steering cover, but the thread is torn out. So there is some observation in a car, but it will not affect the performance of the car. But in the same but the same time, if you look at the steering, and steering is loose or having some vibration, so it will affect the safety or the performance of the car. So you have a multiple points, observations, or in other way I can say that discontinuities. That discontinuities might be affect your performance and might be not affect the performance. So I can say the acceptable observations are discontinuities. All the discontinuities can be accepted, can be rejected. If it is accepted, then you can use that car as it is. But if it is not accepted, then it is considered as a defect. So in a simple manner, the property, if it is not meeting the specification requirement, then it is considered as a defect. Otherwise, you accept as it is. So there is a difference between discontinuity and defect. And in a single line, if I want to say, like, every defect is a discontinuity, but all the discontinuity are not defects. They may be accepted. So Ronak, you can go to the next slide. So no need to rectify all the all the discontinuity. Only defect need to be rectified. All the rest of the discontinuities can be accepted because they are not defects. So there is a basic difference. With this phenomena, we industry works or any code and standards by which we are here to manufacture the product. So this is a basic funda that not required to repair everything. You require to repair defects only and identify defects only. So these are the various defects. Will not cover all the defects, but the basic defects that I'm going to cover because it will take too much time. Ronak, you can go to the next click. There are many defects at various stages, but majority of our fabrication level, like undercut and porosity and burn through, I'm going to cover one by one. So next slide, please. Yeah, very common, and people used to know the welding mein crack aa gaya. So the crack is a very common defect. So I covered in the very first that why this crack is there. So there are a number of possibilities because of that the crack will get cracked after welding. Like first is wrong consumable. If I use the wrong consumable, anyhow the consumable is wrong, then weld will not be matching chemistry of the base material. So it will get cracked. There are other also causes like if I'm not following the procedure. Normally welding engineer used to give the welding procedures like you have to use certain amount of ampere and voltage and speed and consumable and you have to do the preheating of the job. If that technique is not being followed, then that may result into the crack. So that we need to follow the procedure and use the correct filler wire to avoid the cracking. One more is like improper preheating. If I'm doing it is required to do the 150 degrees Celsius of preheating prior to welding. And if I not do that preheating, the cooling rate of the weld metal will be a faster one. If I do the preheat, it actually results into the slow cooling rate. But if I do not do the preheating, the cooling rate of the weldment will be on a higher side. So weld cooled comparatively faster and it become harder. And once it become hardened, it's prone to crack. So because of that, the crack is there. So this crack, there are many causes, and remedial is first. In any case, we need to follow the procedure, use the correct filler wire, and preheat if required. Then we need to rigorously follow. So this is a typical example of crack. Next slide, please. Yeah, here's the image where once the weld is completed in the heat affected zone, HSZ we used to call it, there the crack is there. It's not a visual defect. You can identify by visual, but there are many tools to identify that. I'm going to cover in the subsequent slides. So next slide, please. Yeah. Second is lack of fusion. See, the fusion. In a fusion process, welding is a fusion process, and if we are not doing any fusion with like if I'm doing the welding with the electrode and that weld metal is not getting fused with the base metal, then it is called as a lack of fusion. Fusion is not there, and if the fusion is not there, it is called as a lack of homogeneity. So joint is not homogeneous, and any code or any customer will not allow any lack of fusion in the joint. So lack of fusion are not acceptable. Our joint must be fused, weld metal and base metal must be fused, and joints must be homogeneous. So this lack of fusion has to be avoided. There are many causes because of the lack of fusion is there. First is low ampere. Like certain amount of heat is required to melt the base metal and weld metal. If they are, if we are not, the ampere is not adequate current, then it will not get fused with each other. Second thing is the electrode angle or torch angle. If I'm not able to direct the torch or electrode in a proper manner, the other edge will get unfused. So we have to manipulate the electrode, or we can say the weave the electrode in a proper manner so as the adequate weaving is there and it gets fused with each other, base metal and weld metal. So in a majority of all the defects, if you see, the fabrication is being done by the welder or welding operator. So as a remedy, first of all, we need to correct the current and all that. Torch angle need to be corrected. But the last point that you need to take care is the training to the welder, because if all the process is correct, but the welder is not good, or welders have not sufficient skill to deposit the weld bead, then the defect will be there. So majority of defect you can see, the remedy is training of welders. So even the ASME code or the customer, I can say the customer specification used to say that any welding in a pressure washer or heat exchangers or boiler need to be carry out by the qualified welder, and for that we need to qualify the welder with respect to their position, then pipe diameter. All there are certain criteria by which we have to qualify and upgrade the skill of the welder. So next defect, please. Next slide. Right, this is some example of lack of fusion, like weld bead is there, but it is not fused with the edge. The images of these all are images of some ND methods. So you cannot see the visually, but to identify the defect, there are some ND technique is there, non-destructive examination, that we will share later on. Next slide, please. This is the porosity. Porosity is a very common defect when which damage the homogeneity. Like once the weld is in progress, if any air drought or the electrodes are in a damp condition, it will generate the vapor or may damage the shielding of the arc. So that gas get entrapped in the weld metal. So it resulted into porosity, and porosity, once porosity is there, the joint is not integral, and for that it has to be removed. So the causes are improper shielding gas, like my shielding gas is proper but my torch is leaking. My filler wire is defective, like electrode, the electrode itself having a porous material, so it will not result in the defect-free weld. So electrode itself is the condition. One more thing, when you weld on a carbon steel itself having a rust, iron oxide, FeO2. So if we directly weld on a rusted base metal, the oxygen, the iron and oxygen dissociate, and oxygen will entrap into the weld metal and create the porosity. So we need to clean the base material frequently, mainly just prior to the depositing the weld bead. So these all are the causes, and remedials is in line with the causes, like we need to supply a proper quality of argon gas. We need to prevent that leak of the torch, clean the base metal. These all the remedials. Next slide, please. One more defect is a slag. So if we see is this image of SMAW process. Here in the SMAW process, there are a typical electrode. There is a bare wire which is covered with the flux coating. So that flux will actually serves two purpose. It stabilizes the arc and prevent the contamination of arc from the atmosphere. So in SMAW process, the weld metal is there, and after and above that, that flux will convert into the slag, because it is not a weld metal. That slag we need to remove. So next slide, please. If we do not remove the slag before depositing the second class, that slag will entrap, and that slag is not a metallic material, so it damages the homogeneity. So it is considered as a defect. So the cause is, first is inadequate cleaning. The second thing is the current, like, or angle. If we are in a proper angle, then it also gives the result into the entrapment of the slag. So remedial. So this again, we first is we need to clean that weld metal prior to deposition of second layer, and to sensitize the welders so as they can deposit a good quality of weld. So these are the remedies. Next slide, please. Undercut is nothing but like, if we weld with the higher current, what happens is it fuse with the base metal because of the higher ampere, but it also create, I can say that it can damage the surface of the base metal, like, at the toe of the weld it cuts the base metal. So once it cuts the base metal, the total thickness of that section is reduced. Like, my base metal is 10 mm and my undercut is 1 mm, then my total joint thickness will resultant thickness is 9 mm. So it actually reduces the design thickness. So that's why this undercut not permitted. Small undercut will always be there because of welding, but the excessive undercut, like, there is some criteria, like 1 mm or 10% of nominal thickness is allowed. Whichever is minimum, it is allowed, but more than that, it is not allowed. So the discontinuity and defect the boundary line is this. So causes excessive current or voltage, and that we need to prevent by lowering the ampere. Next is lack of penetration. See, the penetration is actually at the root side, and as the process is fusion, and we have to fuse the base metal top and root, the complete thickness to be fused. If any fusion is not there, then it is called as lack of fusion. But if the same lack of fusion is at the root, there, if you see the image, at the root the edges are not fused. So in other ways, it is called as the root is not fused or penetration is not there. So that is called lack of penetration, and lack of penetration is also not allowed because it is the complete fusion is not there. So there are many reasons, but main reason is the welder is not having a sufficient root gap. Gap is not sufficient between two plates, so he is unable to deposit the weld till to up to the root. Second thing, the root phase. The root phase is so higher that the energy is not sufficient to penetrate the base material. So these two are the basic. Are here, or one more thing is about the direction of arc. If the arc direction is not proper, he cannot deposit till the root. So the main idea is welder has to reach up to the root and fuse that root line. If it is not done, then it is lack of penetration. So next slide, please. Here the welder skill has to be upgraded, and with respect to joint configuration, by which we can avoid. Next is excess penetration. Here is opposite of lack of penetration. Here because of the higher root gap, if the root gap is on a higher side, the weld metal which is deposited by the welder, it actually penetrates excessively on the root side. So this is actually defect, but I can say it can be avoided. Like, if the excess penetration is there, then we can grind it from the back side. So this defect can be avoided, or we can say the corrected with excess penetration. But this is not possible every time. Like, if my pipe is 1 inch, in 1 inch pipe is there, and if I am find the excess penetration in the joint, the grinding of that joint from the root side is not feasible because of the accessibility. So at that time, excess penetration is considered as a defect. If you are able to grind that, then it is not considered as a defect. So next slide, please. Overlap or other word is fold. Like, weld metal is there, but once you deposit a weld metal, that weld metal actually overlap on the weld metal. It overlap more on a weld metal, I can say. That create actually sharp edge at the toe, and that is considered as a defect because it creates the stress risers, and once it creates a stress riser, act as a stress riser, the formation of defect is more. Possibility of formation defect from the toe is very high. So that's why it is called as a defect. Next slide, please. Yeah. Uh, Unlike lack of penetration, in the lack of penetration, weld edge is not fused. But here is one more defect that is called suckback. Here weld edge is fused, but because of the higher heat input, or I can say the higher energy, excessive current or very slow speed, that welded metal gets shrink or sucked back uh, from the root. So here penetration was achieved initially, but because of the slow speed or energy shrinkage, that root gets stuck at the back side. So if we look at on the image, the because of the suck back, total thickness at the given section will reduce. It is though compensated with the reinforcement, but if the suckback is more than the reinforcement, the total thickness will be less. So design thickness is not achieved. We cannot achieve the mechanical property or joint strength for complete section thickness. So it is considered as a defect. So here the root cause is excessive current, or I can say the higher heat input. Because of that is it happens. So we have to avoid, or we can reduce that current level. Next slide, please. Yeah, underflush. It is not actually a defect. Underflush is like you have not filled sufficient amount of weld metal. So it is a very common defect, but it's normally identified by the welder that he has not filled the joint completely. So the remedial is very easy. Just deposit a subsequent fill that balance welding. So that is underflush. Underflush is nothing but you have not weld complete joint. So the remedy is you have to weld the complete joints, but it is considered as a defect because it reduces the thickness of the joint at the given section. Next slide, please. Yeah. The term is burn through. Burn through is like the entire. So sometimes welder what they used to do is to get the proper weld penetration. They increase their ampere. So if they increase the ampere more than the required, instead of welding, the cutting will take place at the root. So at the at the root side, both the base metal get cut. So all I can say the burnout, the edges. So that defect is called as a burn through, and mainly because of the excessive current, or I can say the inadequate current. So that mistake is being done by the welder, and they are because they try to achieve full penetration joint. But unfortunately, because of the higher ampere, they damage the root face. Or so this defect is burn through, and remedial is very easy, like which is reduce the current or root opening, and training is must. Next slide, please. Yeah, tungsten inclusion. Inclusion are many types, like slag inclusion, tungsten inclusion, but that inclusion is considered as a defect because that inclusion is not a metallic particle. They are not intended one. Like tungsten is a metallic one, but it is not intended. The joint is carbon steel or low alloy steel or stainless steel material, but the tungsten is a different material. So and because tungsten having a higher melting point, it will not anyhow melt or fuse with the base material. So lack of fusion is also there. So it is not acceptable. So in the GTAW process, gas tungsten arc welding process, its defect is commonly found when welder by mistake touched the tungsten to the base material and resulted into the tungsten inclusion. So for that, the remedy is we in L&T have a higher frequency unit available with us. Higher frequency unit is a unit which helps welder to strike the arc without touching the electrodes. So welder used to keep 3 to 4 gap between base metal and tungsten, and once he start the power switch on the torch, the arc automatically jumps from the tungsten to base metal. So he do not need to touch the tungsten to the base material. So HF unit is a solution, and yes, we should not touch the tungsten to the base material to strike the arc. Next slide, please. And the last one I can say as a visual or aesthetic point of view. So welder normally have to strike the electrode on a to initiate the arc, to generate the arc. So if we strike the arc on the base metal, then base metal and away from the joint. If we used to strike the arc away from the joint and then quickly move to the joint, so it creates the unnecessary welding on a base material. So if we weld unnecessarily on a base material, it actually changes the metallurgical property of that point, localized metallurgical property. So it will help. It will actually damage that portion. So we need to avoid. Or second is the stray arcing and is the spatter. When we weld, there are number of spatters. Instead of weld depositing in the groove, some few weld particles because of the excessive current deposit on the base metal, which creates the aesthetic point of view. The spatters is and that we need to remove, and also damage the metallurgical properties. So this we need to avoid. Next slide, please. For the specific for fillet and joint, there are few terminology like concavity. If we require certain fillet size, I think we skip 2 slides. Yeah, it's okay. If we require certain fillet size, if we over deposit the weld metal, then it is called as a convexity. Just go to the previous slide. If we deposit a lesser weld metal, like throat is less, leg length is met, but throat is less, then it is called as a concavity. Ideally, it should be perfect triangle, but to achieve the desired throat. But there are 2 defects we can find in fillet: concavity and convexity. Next slide. Next, in a fillet, this also happens like because of the gravity. If I weld the horizontal plane of base metal, the weld metal flows because of the gravity, and it overlap on the base material. So it's a similar overlap that in a butt joint, but it creates the stress riser point. Next slide, please. So these all are the defects, but there are some, why? Because these are defects, because it is unacceptable. So acceptable limits are given in some codes. These are some standard guidelines like lack of fusion or crack are totally not allowed. For this is for the radiography requirement. Like up to 6 mm length is allowed for the 19 mm thickness. This is what I'm going, just one example. How much discontinuity is allowed. So in the 19 mm thickness, 6 mm is discontinuity is allowed. If my discontinuity is 7 mm, then it is considered as a defect. So it is depend on the thickness wise. So for 57 mm, 19 mm, and above 57 mm, 19 mm is maximum. So more than 19 mm, it is not allowed. So next slide. These are the general acceptance criteria. Now our second stage is detect the defect. First one is identify to avoid that defect, but due to manufacturing process you will face many defects. Now we have to identify whether defect is there or not. So very first tool to identify the defect, that is non-destructive examination. Without damaging the job, we have to inspect. Otherwise, if we want to damage the job to identify defect, then it is not a solution, because finally we need to produce the product. We cannot damage that. So we need to inspect that product without damaging. So the examination that we used to do is non-destructive examination. And very first non-destructive examination is visual. Many techniques are there. But very first is visual. Welder or supervisor has to see the joint visually. So few defects which is open to surface can be seen visually. Few defects which is subsurface, like near to surface, it can be identified. We cannot see the defect visually, so we have to find some alternate method. And the subsurface defect, anyhow, we cannot see because it is not transparent project job. So for that, again, we have to do the ND is like radiography, ultrasonic. I will share a small one slide for each ND techniques. Like very first technique is liquid penetrance. If my defect, if I not able to see the defect visually, but defect is already there, I am not able to see the visually. For that, there is one technique. If my surface is defect is on the open to surface, then there is technique like first we have to clean that job and apply one chemical called as a dye. Here the color of that dye is given as a green in the image, but actually it comes in a red color. So we have to apply that red liquid on the surface. Second, the next step is remove that. Ronak, please go to the back slide. Just 1 minute. Yeah, we then remove that slide, dye, and apply one more chemical which comes in a white color that called as a developer. That developer, what that used to do is whatever the dye which is entrapped into the defect, that because of the chemical reaction and capillary action, that dye come out from the joint, that defect, and in a white background the red dye comes out, and we can easily identify that defect. Like if in the last image you can see the white background and there is one red line, that is actually defect, and probably it cannot be identified on a visual examination. So this is the liquid penetrance and very commonly used in the industries. Next slide. Second is like open to surface or subsurface defect. To identify that, there is one technique is magnetic particle test. Here we have to use a magnet, principle of magnet. So material must be magnetic. So for that carbon steel or low alloy steel can be used, but stainless steel you cannot use this technique. So if we generate a magnetic field, and if any defect is there, then the flux line will get disturbed. So with that disturbed line, and if we apply any iron particle on a top of the surface, the iron particle get accumulated. Like in the second image, you can see that there is one magnetic field we have generated, and if any defect is there, that magnetic line disturb, and we have to apply separately iron particle separately. That iron particle get accumulated at one location because of the flux leakage, and by which we can identify the defect. So this is for the subsurface and open to surface defect. Next slide, please. If the defect is not on a top of open to surface or subsurface, we have to do the volumetric examination. Like in our general medical terms, we used to do the X-ray of chest and other parts. The same manner, we can do the X-ray, or I can say in more technical terms, the radiography of the particular product. The principle is same that of medical language, but here the kV, kilovolt of that energy, I can say, is higher than that of the required for the human. So just the example is, just look at the image. One block is there. If any discontinuity, like any section thickness is getting changed, the density of that particular location get changed, and that density change will reflect on the radiograph, like dark and light shade. So by this dark and light shade, you can identify the defect, what is the defect is there. But here the limitation is you cannot identify the defect depth, because the radiograph is a 2D image, not a 3D image. So 2D image you cannot identify the depth. The next slide, please. Just look at few radiographs just for the reference. Normally weld having a reinforcement and penetration. So at weld region there is a higher section thickness, and the base metal having less section thickness. So base metal comes darker in the radiograph. Weld line comes in a white shade, because the less exposure of radiographic film is there. So if any defect is there, like let's take an example of last image, there is suckback, or I can say lack of penetration. Here is a suckback. So if suckback is there, because of that suckback, particular location, the density is coming very less compared to the weld metal. So there is base metal dark line. In center there is a weld metal bright line, but where the suckback is there, the radiation pass from the base, that defect region, and ionize the film more. So the film will become darker one. So this is how we have to interpret it or detect that defect. Next slide, please. Few more example, like if any, I think you can. Okay, it's okay. So next technique is ultrasonic. There is one limitation in radiography, that you cannot identify the depth of the defect. So to overcome that, there is one technique which is works on a piezoelectric effect. Like there is one equipment, this in a first image, that equipment having some transducer. If we apply a current, that transducer generates vibrations, or they are, we can say, the generate the ultrasounds. That ultrasound we have to pass from the base material. In a second image, you can see, if we pass the ultrasound from that base metal, there will be a three echo. First from the top surface, second from the bottom surface. But if any defect is there, the echo there, the path, the ultrasound will reflect back from that defect. So it will generate third echo between initial and back wall surface echo. So by in a display you can see that initial echo is there, back wall surface echo is there, and in between the cracked echo is there. So this is how. So based on the scale, in this display there is a scale that if the base metal thickness is 6 mm or 5 mm, then my defect is at around 3 mm. This is how we can identify the depth of the defect, and by skill of the operator you can also judge what morphology of defect, whether it is cracks, slag, that he can identify. But here he can pick the indication with the depth. So next slide, please. So all the defect, first of all we have to avoid defect. Second thing, we need to detect the defect. So once we have detected defect, the last option is we have to rectify that defect. So all the defect to generate the quality product, defect-free product, there are certain standard practice that we have to follow. First of all, for any defect, we in L&T used to make a procedure, and that procedure we used to give to operator to how to rectify defect. And standard procedure is like that. Here is the horizontal one seam is there, and in between center there is a defect that we have identified. Now with radiograph or UT, once we got the tracing. Tracing is nothing but like a butter paper in which we mark everything, and with that butter paper we mark the defect location on the actual job. Now before doing any grinding or before doing any further rectification, we have to mark some reference lines to identify whether defect is gone or not after grinding. So for that we used to mark defect reference line like 50 mm on the toe side and sideways 100 mm. And with that reference, after grinding, we used to check whether the groove is on a proper location, is there, proper depth we need to ensure. So once the groove is done, we have to check the grooves is completely okay or not. So for that, LP we used to do liquid penetrant examination of that groove area, and if it is found satisfactory, we have to reweld. So cut, grind, and rewelding of that location, and repeat the ND. Like if I found the defect in radiographic examination, then I have to repeat the radiography examination after repair. So this is the standard methodology of repair. So this is how everything that we have covered for detect, avoid defect, detect defect, and rectification of defect. So now you can ask if any queries with you. So I'm happy to share your queries. This is actually the slide I used to share at the last. If I'm unable to answer your question, but don't worry, I will answer your question based of my knowledge.
Yeah. So if anyone has any question, please let me know.
See, to cover everything in 1 hour is always very difficult for me, and to grasp everything in a 1 hour is also difficult for you. So, if any queries pertaining to industrial practice or related to defect or identification or how to rectify defects, so if you have any query, you can contact me at any point of time. Right now, if you do not have any query, so don't worry. I will
Yeah.
leave my details in subsequent slides, and
Yeah.
you can
Sure.
approach me at any point of time.
Yeah, sure, sir. If anyone would be having any query, I will definitely show to your email ID that query, and you
Yeah,
may
yeah,
respond to that query if any doubt to anyone. So I
sure.
would like to thank you, Mr. Kiran sir, for your valuable time to give this webinar on these welding defects and its identification. Thank you very much, sir.
Thank you, Ronak, and I'm sorry for the initial delays because of my connectivity issue.
Yes, sir. It
Thanks
all.
to
Yes, sir.
Parul for providing me opportunity. Thanks, Ronak.
Yeah. Thank you, sir.
Okay.